Okay, so what we're being asked to do on the first two is to determine whether or not they are arithmetic. So the way that we do that is we look to see, are we adding or subtracting the same number going from one term to the next? And if you are, then that means it's arithmetic. So what we're going to do is we're just going to check to make sure that we're doing the same thing. So going from 10 to 8, we subtracted 2. From 8 to 6, we subtracted 2. 6 to 4, we subtract 2. And from 4 to 2, we subtracted 2. So since we subtracted the same number each time, this is arithmetic. Okay, so for this one, we're going to do the same thing. We're looking to see, are we adding the same number? So going from 1 to 4, we add 3. And from 4 to 9, we add 5. Now, since these numbers are different, that means that this is not arithmetic. So it only takes one case for it not to add the same number for it to not be arithmetic. So this one isn't. Okay, so for these, we're being asked to find a particular term. So we're going to use this formula here, which is what's called the nth term of an arithmetic sequence formula. So the nth term is equal to A1, which is our first term, plus D, which is our common difference. That's the number we add or subtract each time, times N, which is the term number we're looking for, minus 1. So here on this problem, they tell us the first term is 5, the second term is 11, and they want us to find the 10th term. So we're going to use the formula down below to help us do that. We're looking for the 10th term, so I'm going to plug in a 10 for the subscript there. Is equal to A1. A1 is our first term, which in this case is 5. Now the common difference is the number that we add going from one term to the next. So if our first term is 5 and our second term is 11, going from 5 to 11, we add 6. So that's going to be D, our common difference. And since we are looking for the 10th term, that is what N is going to be. So all we have to do now is to evaluate this expression, and that'll tell us exactly what the 10th term is. So here, 10 minus 1 is 9, times 6 is 54, plus 5 would be 59. Okay, number 4, we're being asked to do the same thing. This time we're being asked to find the 7th term. So again, we're going to use this same formula down here. So we're looking for the 7th term. So we have A of 7. And we're going to set that equal to our first term, which is 4.4. Plus D. Now D is the common difference. So going from 4.4 to 6.6, we add a 2.2. So it's going to be D times N minus 1. Now in this case, N is going to be 7. So all we need to do now is to evaluate this expression. So 7 minus 1 is 6 times 2.2 is 13.2. And then we're going to add that 4.4, which is 17.6. Okay, so on 5 and 6, we are being asked to find the sum of the first however many terms. So the subscript number tells you, so the first one is S of 10. We're adding the first 10 terms together. So we're going to be using this formula down here. So S of n just means the sum of the first n terms is equal to n, which is the number of terms, divided by 2, times the first term plus A of n, which is our last term, in this case the 10th term. So this is going to be kind of a two-parter because we do need some extra information. Now, what we need here is, since we're looking for the 10th term, that is what a of n is going to be. So we need to find that first. So to find the 10th term, we're going to use that formula from earlier, which is a of 1, which in this case is 8, plus our common difference. So that's what we add going from one term to the next. So going from 8 to 20, we added 12. Here we added 12. Here we added 12. So our common difference is 12. And then we're going to multiply that by n, which is 10 minus 1. So that's 9 times 12 is 108, plus 8 would be 116. So our 10th term is 116. Now the reason we need that is because that's what we're going to plug in here. We know our first term, a1, that's what they gave us here. And we know n because that's what they gave us here. So we're going to follow this formula now. So we're looking for s of 10. And that's going to equal n, which is 10 divided by 2. Times our first term, which was 8, plus our last term, which was 116. So now all we got to do is to evaluate this side, and that'll tell us our answer. So if we add those together, it should be 124. And then we're going to multiply that by 10 divided by 2, which is 5. So we get 620. So that's basically saying if you were to continue this pattern out to the 10th term and then added all those numbers together, they would add up to 620. Okay, so this one's going to be worked just like number 5. This time, though, we're being asked to find the 100th, or the sum of the first 100 terms. So we do need to find out what the 100th term of this one would be. This one's kind of easy because you can see that first term is 1, second term is 2, third term is 3, fourth term is 4. So, so our 100th term in this case would be 100. And you could find that if you really wanted to. You wanted to follow the formula. So we take our first term plus our common difference, which we're adding 1 each time, times n, which is 100, minus 1. So that's 99 times 1. So we end up with 1 plus 99, which is 100. So we have all the information we need now. So we have s of 100. So we're going to follow this formula. So we have n divided by 2. So n, in this case, is 100. And we're going to multiply that by the first term, which is 1, plus our last term, which was 100. So what we have here is we add that together, we get 101. And then we're going to multiply that by 100 divided by 2, which is 50. So we get 5,000.